Welcome to the deep dive. Today we're tackling a real classic problem, aren't we?
We are indeed. That infamous front shock mount breakage.
Yeah, on the Tamiya Grasshopper, the Hornet, Grasshopper to second, Super Hornet, you, our listener, have flagged this a lot.
It's definitely a common frustration. And people are looking for fixes beyond just, grabbing another chassis tub.
Right, that Tamiya part, #033 Fizzy50. It's like $15, but maybe we can do better. Or just different.
Exactly. So this is about understanding why it breaks and exploring, well, all the clever ways people have found to deal with it.
So for you, the learner, this is about getting that practical insight. We'll look at the root cause.
And then the fixes, from simple repairs to some quite involved performance mods.
Yeah, hopefully some real aha moments without getting bogged down. Our mission, to get you feeling confident tackling this.
Whether you need a quick patch-up or something really robust long-term.
Okay, let's get into it. Why do these things actually break so often? What's the deal with the design?
Well, it comes down to how that stress is focused. The stock setup is just a screw, right?
Yeah, going straight through that molded tower that's part of the main chassis tub.
And that tub is ABS plastic. Now, ABS is decent stuff, usually, but over time, and especially with impacts, jumps, whatever, it can get brittle. It just fatigues.
Okay, so the material itself can weaken.
Yeah, and you have to remember the context, too. These were entry-level kits back in the day.
Right, designed to be simple, affordable.
Exactly. So simplicity and cost saving were probably prioritized over, let's say, ultimate resilience in this one specific spot. It was a design compromise.
Makes sense. Simple design, aging plastic, focused stress, recipe for breakage?
Pretty much.
Okay, so picture this. Our listener's got a buggy with a snapped mount right now. What's strategy one? Repairing it.
Yeah, the first route is definitely trying to repair and maybe reinforce the original mount.
How do you start? Just slap some glue on.
Well, no, not quite. Prep is crucial. First, you gotta clean those broken edges really well.
Like with alcohol.
Isopropyl alcohol is perfect. Get rid of any dirt, oil, grime. Then you need precise alignment. Make sure the pieces fit back together exactly right.
Okay.
And some people even carefully carve a little V-groove along the brake line.
Oh, why's that?
Gives the adhesive a bit more surface area to grab onto. Better bond.
Clever. All right, so it's clean, it's lined up. What kind of glue?
Or bonding agent.
You've got options. Two-part epoxies made for plastics are a really good bet. Things like JB Weld Plastic Bonder or Plastic Weld. They create a strong chemical bond. Even standard JB Weld, the steel reinforced stuff, can work if you rough up the plastic surface first. Really meticulous prep is key there.
And you gotta mix them, right? The two parts.
Absolutely critical. Follow the instructions on the package for the mix ratio and, importantly, the cure time. Some are 5-minute epoxies, others take longer.
Does longer cure mean stronger?
Often, yeah. The slower cure generally gives a tougher, less brittle bond in the long run. Epoxy's strong, but can sometimes be a bit too rigid on its own.
Okay. What about ABS cement, since the chassis is ABS? That's another excellent way to go. Tamiya sells their own, or you can use the stuff plumbers use.
How does that work? Is it just glue?
It's more like chemical welding.
Yeah.
It actually softens and fuses the ABS plastic surfaces together on a molecular level.
Whoa.
Yeah. So good contact between the broken pieces is absolutely vital, and it needs time. Tamiya's can take like 2-3 days to reach full strength.
Okay, so patience needed there. Any other welding type fixes?
You could try actual plastic welding. A low wattage soldering iron can carefully melt the plastic along the crack.
Tricky though.
Can be. Or hot air guns with specific ABS filler rods. They're even hot staple welders now.
Staples, like office staples.
No. These are little metal staples that a special tool heats up and beds across the crack. Really strong mechanically.
Sounds intense.
It is. And definitely need good ventilation for fumes with any melting and eye protection for those staples. They can fly.
Good safety callouts. What about the quick fix I always see online? Super glue and baking soda.
Yes. Look, CA glue, super glue mixed with baking soda creates a very hard, very fast-setting filler.
Cut.
But it's usually quite brittle. For a shock mount that's going to take hits, probably not going to last. Maybe a temporary patch at best.
Right. So just gluing it, even with good epoxy or cement, might not be enough on its own.
Often, no. Especially if you drive it hard. That's where reinforcement comes in. This is key for durability.
Okay, how do you reinforce it?
A really effective technique is internal pinning. You drill a small hole across the brake line.
Right through both pieces.
Exactly. Then you insert a small rigid pin like the shank of a drill bit or a bit of stiff metal wire coated in epoxy.
Ah, like rebar in concrete.
Precisely. It dramatically increases the strength across that joint. Another way is external bracing.
What's that involved?
Bonding some extra material over the repaired area. Could be a patch of plastic sheet like styrene or more ABS, or fiberglass mesh or cloth saturated with epoxy, or even something like shoe goo. Some people even use thin metal plates shaped to fit. Spreads the load out.
Okay, lots of ways to make it stronger.
Yeah, the effort you put into reinforcement really pays off in how long the repair lasts. Simple glue often just fails again.
Got it. So that's strategy one, repair and reinforce. But what if someone wants something, well, fundamentally stronger, or wants to upgrade?
Then you move into strategy two, modification, creating
Oh.
entirely new, stronger mounting points.
Which means getting rid of the old broken ones first.
Usually, yeah, carefully cutting or grinding away the damaged tower section.
And then what? Build something new.
You could. Some folks with the skills and tools fabricate their own mounts, often out of metal, like Turbo Timmy 88 you mentioned, using metal to get more suspension travel and fit different shocks.
That sounds pretty involved, though. Metal fab isn't for everyone.
True. A much more common and accessible mod uses specific U-shaped brackets.
U-brackets?
Yeah, Tamiya actually makes some part #9805082. They're originally from the Lunchbox kit, I think.
Okay, how do they work?
You bolt these brackets directly onto the flat part of the chassis, basically where the old towers were. They provide a new, super sturdy mounting point.
And you can attach shocks to these brackets.
Exactly. But you generally need oil-filled shocks that have an eyelet mounting hole at the top, not the old screw-through type.
Ah, like the Tamiya CVA mini shocks. Those yellow ones.
Perfect example. The #505on18 or #50746 CVAs work great. You mount them to the U-brackets using standard RC hardware.
Like M3 rods? What are those?
Little threaded metal bars, you'd use those with ball connectors.
The pivot points.
Yep, and ball connector nuts, cap screws, basically small bolts, and maybe some brass spacers to get the alignment just right.
Okay, so it needs a few extra parts, but you get a much stronger mount and an oil shock upgrade.
That's the big win. It fixes the weak point and improves suspension performance dramatically. Better damping, better handling.
Nice. What about the modern solution? 3D printing.
Oh yeah, the 3D printing theme for this is fantastic. AMPRO Engineering Pinto Power is probably the best known.
What do they offer?
A huge range of stuff. Reinforced versions of the stock mounts, completely redesigned front suspension geometry, parts specifically made for modern shocks. Really clever designs.
And how do you get these?
You can often buy the physical prints directly, sometimes through services like Shapeways. That can be a bit pricey though.
Right.
Or, increasingly, you can buy the STL files and print them yourself if you have a 3D printer. Much cheaper if you have the gear.
What kind of plastic should you use for printing these?
For structural parts, like shock mounts, something tough. PTG is good. Nylon is even better if your printer can handle it. Definitely not standard PLA. It's too brittle.
Good tip. Are there other 3D print options besides AMPRO?
Oh, tons. Check places like Cults 3D, Thingiverse, like Minifactory, lots of user-designed parts. Quality can vary a lot, though, so read comments, look at pictures.
So lots of options there, from DIY metal to specific brackets to high-tech 3D prints.
It's really evolved, addresses the root cause, and opens the door to better performance.
Okay, wrapping this up then. Repair versus modify. How does our listener choose?
It really depends on a few things. Your budget, how comfortable you are tinkering, and what you want to do with the buggy.
So maybe like quick and cheap.
A careful epoxy repair might hold for light use. Maybe.
Durable, but still budget conscious.
Epoxy or ABS cement, definitely reinforced with pinning or bracing. That can be really strong if done well.
And for best performance, ultimate durability.
The U-bracket mod with CVA shocks is a proven winner. Or investing in well-designed, well-printed 3D parts from someone like AMPRO, especially if you run the buggy hard.
It's kind of weighing the cost and effort against just buying that new $15 chassis tub, isn't it?
It is. But, breaking stuff is just part of RC. And fixing it, especially improving it, that's where a lot of the fun and learning comes in.
Absolutely. It's a chance to understand your machine better, make it your own.
Precisely. So approach it methodically, pick the right path for you, and, honestly, take some satisfaction in bringing it back stronger.
Well said. Okay, that's our deep dive on sorting out those pesky Grasshopper and Hornet French shock mounts. Hopefully you feel ready to tackle it now.
Yeah, good luck with your repairs or mods.
And maybe a final thought to leave you with. Think about this less as just fixing a broken part and more as your first step into customizing and maybe even improving the performance DNA of your classic buggy. It opens up possibilities. Until next time, happy driving.